by now you've had a chance to work with data prep operators, and you may have strung together a fair number of them to get things done. Now, you might recall we've done a little regression, and if we look and see that we have some data prep and regression work, we're starting to get a little bit crowded in our process workspace here. So what we can do is start to organize using subprocesses. Let's see how that works. Okay, so I'm going to drag a subprocess in here, and you'll see what I get is an operator here that looks like basically two boxes stacked on top of each other. What that tells me is we have another process buried within this operator. So if I click on it, you can see I've got a new blank process workspace to work with. And I can also see where I am in the process hierarchy right at this level. So I can go up one level, take me back to the main process, or if I happen to have subprocesses within subprocesses, I could just click any level and get to that level. So let's get to subprocesses, and let's call this one data retrieval. And initial prep. All right, and then I'll add a little note. Retrieve data set and basic prep. All right. And I'll even specify that this is a sub-process. Okay, so now I'll say, well, I definitely want to, what I'm doing in these is I'm parsing numbers. So I'm basically taking children, which comes in if I do a breakpoint here and run it, and has been interpreted as a nominal feature. Okay, so I'm basically just going to convert that from nominal to numeric, and I'm using the parse numbers option there instead of the nominal to numerical, because what nominal to numerical would do is it would assign the first value that it encounters as value number 0 and work its way from there, 2, 3. So if I go and look at my data set again, yeah, children 0 would be 0, children 1 would be 1, children 3 would be 2, and then children 2 would be 4. So it's not really doing what we would expect it to do. And the parse numbers is a good one for that, because what it does is it converts anything, and it looks for something that looks like a number in it, and it will convert it to that number itself, so that we get a nice, let me do a breakpoint after again, so we can do a little quick comparison. So I've got children 0, 1, 3, 0, 0, 0. And I have still over here children 0, 1, 3, 0, 0, 0. Let's see what would have happened if we did do a nominal to numerical. So I'll do one of those instead. Whoops. And put a breakpoint after that. I'm going to disable this operator, take my wire down there. I will do a breakpoint after, no, breakpoint after. So I'm going to tell it to take my children attribute and create unique integers. Okay. All right. So let's see what we get there. All right, so we had 013, 0001, 3. Okay, now if I run it again, I get 012, 0012, 3. So the numbers are basically coded as it encounters it because it's just considering them another categorical value, not an actual number. So we'll get rid of that, go back to our parse numbers, and go from there. Remove all. So this is a nice option. We can set breakpoints after each step just to kind of see where we are. And that's a good thing to do if you have a complicated process and you want to make a minor change to it. You can set a breakpoint in so that you can stop, take a look at it, and then end the process before you get into your more resource-intensive activities. All right, convert children from nominal to numeric using parse numbers. I'm setting the role. Basically, I'm going to say charges is my label. That's something we do in our machine learning activities. Now I'm doing a regular nominal to numerical, and I'm creating dummy codes for all of my nominals. And I'll select the attributes, region, sex, smoker. Now this next select attributes I'm using because the nominal to numerical dummy coding creates a dummy code for every value of your categorical. And for a regression in particular, we don't want all those to be there, and that's going to give us collinearity problems. So what we'll do here is I'm basically taking those last values out, and then I'm also taking my already numeric versions of those categoricals out. So again, in regression, I can use both approaches. All right, so let's see how we can start to streamline this. So I'm going to take my retrieve insurance, parse numbers, and set role. Let's see, I'm going to highlight all 3 of those. I'll draw a box around all 3 of those. And now I'm going to Control-C, cut, Control-X, cut, and I'll paste them in here. Okay, so now I've got them here. And let's see, what do I want? I just want my set role examples to go out the end here. So now I've got a nice clean data retrieval and initial prep sub-process that I'm ready to move forward with. Let's think about what we're doing next. We're converting nominal to numeric. We're basically creating dummies. We're selecting attributes. So what are we doing those for? Well, we're doing those specifically for the algorithm we've selected, which is a linear regression. So I'm going to create another sub-process, and we'll call this, let's see, linear regression data prep. Okay. And I'll add a note. All right, so we've got a fair amount of flexibility in how we document these things. Be sure when you get an assignment to pay attention to how you are asked to document your operators, etc. in that assignment. All right, so now I can take my nominal to numerical and cut those and paste those in here. And right now it's giving me an argument because it says I don't have anything to really connect there. So what I'll do is I'll connect the output of that first sub-process to the input of regression data prep. And now everything goes through cleanly with just the gray box, no red. And here you can see I'm splitting the data 80-20, so using a holdout approach. And I can bring in another sub-process here, and we'll call this modeling sub-process. And we'll just call it modeling. And then down here, I will mention that this is a subprocess with modeling efforts. All right. So here I can take my split, and I'll take all of these. And put them in my modeling. And now I have a little bit of room to spread them out so that I can neaten things up a bit. Let's see, in this case I will. All right, so we'll bring that in. I've got an input port now. If I end up dragging things around too much, you can see I hide my input and output walls, my results wall and my input walls. I can always kind of squeeze it back and make things fit by clicking this little shrink process button. All right, so that makes it all fit right back within my space. Let's do that one more time after I have done this. All right, so now I've got a split data, linear regression. I'm going to apply my model. I will check the performance of the model. And then I can send the performance of the model to my output port. I can send the actual model out to the output port. I can send my weights, model weights out to the output port. In a regression, that's fairly redundant because the weights will be the same as my coefficients. And then I can actually send the data itself back out to an output port. All right. So now I go back up and I'll connect all my output ports from my modeling subprocess to my wall, my results wall, and I've got myself a nice, clean looking process. It's well documented now, and I can dig into each piece and see exactly what I'm doing. Now, this warning here just says, hey, this is coming from your local repository, so it may not be available if you run this process on a different machine, maybe. All right, so let's run this process and see what we get. All right, so I've got my charges, I've got my prediction, I've got my attribute weights for my linear regression. And I can sort those in descending order. So smoker, yes, obviously my most important weight. Look at the size of that. And then children, BMI, age. With these really not having a weight at all. Now, if I look at my regression coefficients, I have actually, in my regression, told it to select features using a t-test. So in my results, my linear regression has eliminated those features from my regression that don't provide me value. And then in the performance vector, or provide value below my threshold here, which is 0.05. And then for my performance vector, I can see my performance measures here. 0.779 for my correlation. Now, if I were to be a little bit more lenient like we were, say, in our Excel version of this, let's run that again. Now I bring in, let's see, it looks like I may have brought in a couple more attributes. So here's my regression equation now, and my R squared, 0.78. So it did go up a little bit when I loosened my criteria a little bit. All right, so so we've revisited our regression. We have done some subprocesses, modeling, split data, linear regression, apply model, performance. All right, so one other way we can do this is instead of using a subprocess here, let's take a look at another way we can do this. So I'm going to bring all of this back out into my main process. And I'll delete that. So in many cases, instead of using this split data that sends things out two ways, and I set up my process to look like that, we actually have an operator that works as a subprocess container for us that'll help organize all this for me. So let me see if I can find that. Yeah, split validation. So it's under validation, and it is a separate operator, not in one of the folders. So now I bring that in, and you can see this is a split validation. I'm going to actually rename it just to make sure that we specify split validation. All right, so I've documented it, and now if I go in here, you'll see I actually have two subprocesses side by side. So this first one is what I'm going to build the model with. So this is my training side. This side is how I am going to test and evaluate model performance. So the testing side. All right, so in this case, I do not need this anymore now. In this case, I had an 80-20 split holdout, or spit holdout, since I can't spell. Probably a good idea to put that back in my note here. Whoop. So I'll just go and update it here with 80-20 in parentheses. All right, and you'll see right now the default is 0.7, so I'll just change that to 0.8. My sampling type is automatic, but I could also do a stratified sample and then define some details of how I want to stratify it. I'll go back with the automatic. All right, so now I don't need this split data operator anymore. I will copy the... First, I'll connect my regression data prep to my split validation subprocess. And then I'm going to copy or cut my linear regression operator and paste it on this side here. So I'm going to paste it into my training subprocess. Then I'm going to go back to my main process, and I'll grab my other two. Cut those, and I'll paste those in my testing side. So now I will bring in my model. My unlabeled data will now be my test holdout data. And let's see, I will send my performance data out through there. And then what do I have coming out? Mod, train, have. So I want my weights to go through as well. So I'm going to go ahead and connect those. All right, so now I have basically the four things I had before that I could connect to my output wall. At this point, if I want to see the model applied against all my data, well, then I can take the original data I had back here after my regression data prep. I'll bring in a multiply and drop that on top. Okay, so I'm sending it to my split validation by default. I don't need to see my training data. I was just looking at that, and that's just data that I have not applied the model to. So what I'd like to do is see how the model works. So I'll do the apply model again. So if I go to scoring, apply model, I'll bring that over here. And I'll take my model and drag it down here. And then I still want to see my model results, my model when I'm done. I'll take the multiply as a way that I can use the same output more than once. So every time I connect it, a new output port is created. I can use as many of these same items. It could be a model, it could be a data set, it could be a data prep step, you name it. So I'll apply the model. I see the model itself is going. I also want to see the labeled output. I've got my other two items from the split validation. That is my performance metric, and then also the weights, the model weights that I have. So let's run that. All right, so now I have my actual results and my predicted results, my features that I have kept in the model, my weights, and then I can see my performance, 0.78. All right, so we've cleaned up our efforts a little bit by using subprocesses. And that's a good way to give us the ability to put more into our workspace, more on our modeling canvas here, if you will. If I really wanted to clean this up, I could then take the multiply, put it here at the end of my regression data prep. And then just create two outputs. All right, so that's a little bit cleaner. I can go back here now, send the first output to my split validation, the second one to my apply model. All right, so slowly but surely, we're just sort of cleaning up and organizing our process. Okay? One last thing to note. When we set up our split validation, you can see a checkbox there called Use Local Random Seed. Now, if you want to be able to replicate your results exactly, this is something you want to turn on, because if I do a local seed, if I don't turn this on, basically whenever I run it, my 80-20 split is going to be different. So if I turn my local seed on, and then you'll see it defaults to something, but I'm going to type in my own local random seed. I'll use 1, 2, 3, 4, 5, 6. Now you should use something that works for you. And if you're in my class, you'll use the one that I have assigned to you or your group. So be sure to find that and use that for any time you see this local random seed. Okay, so now I'm going to get the exact same split and holdout anytime I run this. You'll also find sometimes with your model, depending on the model approach, like decision trees or k-nearest neighbors, etc., that might have different starting points that can be assigned randomly. You can also find a local random seed in the actual algorithm operator as well as other operators. So keep an eye out for that. Whenever you see it, you might want to be able to use it so you can be sure that your results can be replicated. Now, of course, if you wanted to run this many, many times to ensure consistency of your results, well, then you would want to leave that off and then just run it a bunch of times to see how consistent your results are from run to run. Okay, so with that, let's get back and see what we'd like to do next.